Hello students, I am SP Basavaraj. This presentation for you is a limited demonstration regarding the experiment transistor characteristics. With this, you may prepare a little better for your practical examination. You have already done this experiment in your regular class. Now I am providing here just a quick glance of the experimental unit and of basically the corrections you are required to make in it. This is the experimental unit to study the current voltage characteristics of an NPN transistor in the common emitter circuit. On the upper elevated part, on the left is a microammeter and on the right there is a voltmeter. In the middle, this is milliammeter. In the lower part of the chassis, there are three sections. Left side between these two terminals here is a DC power supply of 5 volts. On the right side between these two terminals here is a power supply of 12 volts DC with two knobs to vary the voltage, one for coarse variation and the other one for fine variation. The functional part of the circuit is spread in the middle. In its central part, there is a socket for connecting the transistor, and this is a transistor. You see here a notch. The lead nearest to it is the emitter, the lead next to the emitter is the base, and the remaining one is the collector. This white support to which the transistor is soldered is called the relay mate connector. Insert the relay mate connector into the socket. The three leads of the transistor will then be automatically in place in the circuit. Turn all the three knobs to minimum position and then switch on the unit. You are required to study two types of characteristics. One is input characteristics and the other one is output characteristics. Now let us see about the input characteristics. 6 connections are required to be made. They are: number 1 and 2, connect the power supplies on the two sides to the main circuit. Number 3, connect the microammeter to the circuit between these two terminals with positive terminal of the microammeter to the positive point of the circuit and the other one to the negative point of the circuit. Number 4, connect the two terminals of the milliammeter to these two terminals matching their polarities. Number 5, connect the two terminals of the voltmeter to these two terminals matching their polarities. Now the voltmeter measures VCE. Adjust VCE to 2 volts by turning these knobs. Note down VCE equal to 2 volts. Number 6. The positive lead connecting the voltmeter to the circuit in the output side is disconnected at the circuit end, and then connect the same lead to the positive point in the input side. Since all the lower terminals are interconnected in the negative side, no need to change the negative terminal connections. The voltmeter measures VBE. These are the input characteristic connections. After completing the connections, the setup looks like this. VBE is varied from 0 to 0.8 volt in steps of 0.1 volt, and the corresponding current readings in the microammeter is noted along with VBE. After a couple of observations, get the approval of the examiner. Leave all the connections as they are. Now let us see about the output characteristics. Turn all the knobs to their minimum positions. There is only one connection to be made now, which is actually a reconnection of the voltmeter. The lead connected from voltmeter to the positive point on the circuit in the input side is disconnected, and the same lead is connected to the positive point on the output side. Now the voltmeter measures VCE. By turning the input power supply knob, the base current IB is varied so that the microammeter reads 50 microamps. Keeping IB constant, VCE is varied from 0 to 12 volts slowly in the beginning and then in steps of 1 volt. VCE and the corresponding collector current IC are noted. The same is repeated by keeping IB equal to 80 microamperes and then at 120 microamperes. Then by plotting the I versus V for both the cases in the graph, you get the input and output characteristic curves. As preparation for the examination, practice drawing the circuit diagram and tabular columns and memorize the formulae. Also plot the graphs by taking the values from your practical record. Further calculate the input resistance from the input characteristic curve, and then the output resistance and the amplification factor from the output characteristic curves. That's about your preparation. Remember, listen to the instructions given by the examiner carefully at the start of the examination and follow the same. That's all, students. I hope this video helped you a bit in your preparation for the practical examination. Thanks for watching.